Greetings! In this video, I discuss using an old laptop computer on your electronics workbench. I'll also cover Linux topics such as distros, working in the terminal, and desktop environment choices. Plus, we'll probe internet privacy, software minimalism, and saving money. Let's commence with a real-world example where I measure something on the bench and then use a computer to calculate the result. After taking two measurements, let's calculate the return loss of a 50 ohm resistor using a C program I wrote for the Linux terminal. Within many command line or terminal programs, you can call up a little usage screen, just some strings that tell you how to use the program, and that's what you're seeing here. This program is called RL, and to execute it in the command line, you type ./RL followed by two floating point values. These are actually two peak-to-peak voltages. Within that usage screen, I actually have the whole bench procedure. So we need to get two peak-to-peak voltages, one open circuit, and one measuring the port under question. We'll need a sine wave signal generator with a 50 ohm output impedance, here set to 125 megahertz. We'll also need a 50 ohm detector. Here I'm using an oscilloscope or DSO with a 50 ohm terminator on channel 2. You'll also need a return loss bridge, also called a hybrid combiner. To the right of the bridge, you can see a 50 ohm termination resistor. I'll measure the return loss of that 50 ohm termination resistor at 125 megahertz. An orchid decorating your bench seems nice, but is completely optional. For sake of clarity, I'll give a definition of return loss. A signal traveling down a transmission path can be reflected from an impedance mismatch and returned to the near end. The level of the return signal relative to the transmitted signal is the return loss. You may hear radio amateurs refer to this reflection as the match or VSWR, things like that. I've got the camera pointed at the DSO, and the 250 millivolt peak-to-peak sine wave is the open circuit voltage. It's wavering as I thread on the SMA-connected 50 ohm resistor. Eventually, I get the connector tightened, and it flatlines, and I have to turn up the vertical gain on the scope. Good show. We've got the two required peak-to-peak voltages, 250 and 3.9 millivolts. Within our bench laptop, we'll type in ./RL 250 3.9 and calculate a return loss of 36.1 dB. No question, an electronics workbench laptop feels useful. Why would you consider installing Linux on your laptop? We have many reasons. However, the elephant in the room is privacy. As citizens and homebrew nerds, many of us are working to harden our privacy. Using big tech operating systems which feature embedded AI, literally taking screenshots, plus constantly sending these and other data packets via telemetry to the mothership seems frightening and immoral to many of us. Using free and open source software is consistent with our behavior and beliefs as homebrew hobbyists who share and teach others about our wonderful electronic hobbies. Further, the Linux kernel and many desktop environments don't require the latest, greatest, fastest computer hardware. Using pictures and video, I'll go over two outdated laptops in which I recently installed versions of Linux. Both of these laptops performed amazingly well. However, I wouldn't use such an old laptop for perhaps rendering large videos and things like that. Laptop number one, which is my main bench laptop, I got this for nothing. I like free stuff. It has a great keyboard and a very crisp video screen. Here are the specs. This is a 2008 Dell Vostro business computer with an Intel CPU and GPU. It came with 3 gigs of DDR2 RAM, a DVD CD-ROM, and a 64-bit version of Windows XP as the operating system. The 300 gig hard drive was an old magnetic type and not solid state. You're going to have to choose a distribution of Linux to put on your laptop, and there's a ton of them. It boils down to three things: your needs, your preferences, and your hardware. If you're an absolute Linux beginner and your research shows that your hardware can take it, Linux Mint is a great choice. After working with and learning 6 different distributions, my personal favorite is Arch Linux, but I wouldn't recommend Arch Linux for a newbie. You'll also need to choose the desktop environment that you're going to run on top of your chosen distribution. Some distributions of Linux are very customizable and offer different desktop environments. If you're running an old laptop, you may not be able to choose a fancy and sophisticated desktop environment because it'll place too much burden on your CPU and GPU. Instead, you might choose a lightweight desktop environment such as XFCE. After deliberation, I chose Debian with XFCE to install on my Dell laptop. Specifically, I chose Debian 12 or Bookworm as it's a very stable release, and Debian's been around a long time. The Debian community hosts a website called Installing Debian On, and they show Debian compatibility with various pieces of hardware. I was able to look up Dell, find my computer series, and then view a report. While the report was for Debian 5, an older version, it rang true for my Debian 12 version. The kernel, the network card, the DVD-ROM, and the SATA hard drive all had thumbs up, gave me the confidence to install it, and I did install it perfectly with no glitches. Debian 12 works perfectly on this old laptop, and it's never crashed. Here's laptop number 2. My brother brought me this laptop. He purchased it at an auction for cheap a few years ago, and he wanted Linux on it. I asked him which distro would you prefer, and the only one he knew was Ubuntu. This laptop was an HP Stream from 2015. Intel CPU, GPU, came with 2 gigs of RAM, and only 32 gigabytes of storage. There was no external Ethernet port. All internet connectivity gets done through a WLAN card through Wi-Fi. This was a Broadcom card, and I could not find drivers for it on the HP website. It came with Windows 8, a version of Windows I've never actually used. I had read about a version of Ubuntu called Lubuntu, so I went onto their website. I liked what I saw, and I also learned that Lubuntu sports a desktop environment called LXQT. I also went to the LXQT website and checked them out. It looked really good. Probably the easiest way to put a distro on your laptop is to make a bootable USB disk. Each distro provides information about making a bootable USB disk. Please don't skip the step where you download the key signature and verify that you have an authentic copy of that distro's install ISO file. Let's go back to my concern about the WLAN network drivers needed to power the Wi-Fi on this HP laptop. I searched on the Lubuntu install disk and could not find any drivers. That told me that I needed to go online and find those drivers and download them from a Linux repository. Using a search engine online, I looked around for a few minutes and was drawn to an URL called ubuntupackages.org. On this web page, I found the instructions to download and install the needed Broadcom network drivers right on that HP laptop running Lubuntu. To put my brother's blue HP laptop online, I connected a USB to wired Ethernet adapter and put it online. Since I gave my brother back his laptop, I'm using my Dell laptop for this demo. I opened a terminal window on that HP laptop and typed sudo apt update and upgrade and waited for all the packages to update and install. I then typed sudo apt install bcmwl -kernel-source and installed the drivers. I then removed the wired Ethernet adapter from its USB port and rebooted the laptop. When Lubuntu started up, it flashed me a screen with nearby Wi-Fi networks. I chose our network, put in the password, and the laptop worked perfectly thereafter. Happy ending. I provided 2 examples of successfully loading Linux on old laptops. But what about your laptop? Will you find Linux compatibility with your old laptop? There are abundant resources online, and it takes time to read through them, just like it takes time to read through all the Linux tutorials and learn Linux. If you own an old laptop and you can't safely run big tech operating systems with it, it might be worth just taking a chance. Before I move on to the last section, I'll stop here and clarify about use of the terminal. Rest assured that if you downloaded Linux Mint, Cinnamon, you could entirely manage your computer system without using the terminal. You would use the mouse and keyboard and run all your programs using a graphical user interface, just like you would with Windows or Mac. I'm sure there are other distros that allow their users to manage without using the terminal. Choose a distro according to your needs. I'm a strong proponent of computer minimalism. Consider going to suckless.org/philosophy to view some aspects of minimalism. For example, programs should be simple, clear, and frugal. I feel that electronic hobbyists should consider learning 1 or more programming languages. For example, C or C++, JavaScript, or Python. I write mostly in C, and I'm learning Python. I think it's so cool that I can write, debug, compile, and run my code all in the Bash terminal in Linux. I'm writing a collection of C programs to boost workflow on my bench. Currently, I'm working on a Linux terminal version of an old program I wrote in the 90s called npm bias, which is for Windows. I have it linked on my blog. In the Linux Bash terminal version, I hope to add some small signal analysis capability. Here's a very simple program called par that puts 2 to 4 resistors in parallel. I use it for finding parallel combinations of resistors to critically biased circuitry. The resistors are passed as arguments to the program, and the code keeps track of how many arguments you pass to it. I'm using 1 kilo ohm resistors to keep it simple. We'll quickly look at the source code for par in the terminal using a text editor called Nano. In this very simple application, I don't do much error checking on the input other than disallowing less than 2 or greater than 4 resistor values. I do, however, check the calculated output. Output calculations that yield less than 0, infinity, negative infinity, or not a number are disallowed and an error message shows up. Even if you don't know how to program C, you can copy and paste C code into a text file, and using the GNU compiler, you may compile that code into an executable program and use it. Although I mostly use the terminal on my bench laptop, it's useful to run a browser for stuff like getting data sheets for the parts you're using on your bench. Here I'm searching for and getting a datasheet on my favorite transistor, the 2N4401. We've come to the end, and I hope at the very least you feel my passion for Linux and how it can improve hobby electronics. I'll put some resources on my blog underneath this video in the next couple of days or so. Thank you and all the best.